Hello students, now we are going to see the first example number 1, which says that consider the numbers 4 power n, means all the number which will be in the form of 4 power n can be any natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. For example, they want to say here, if suppose n you will take natural number and natural number starts from 1. So 4 power 1 is what? 4. 4 power 2 is what? 16. So like this, is any number will end with 0, that they are asking. So see what solution they have given and how you have to write it in exam. We will use fundamental theorem of arithmetic here to solve this. Okay, if the number 4 power n for any n were to end with the digit 0, then it would be divisible by 5. This is very important thing. If this has to end with 0, then its prime factorization should have 5, and not only 5, it should have 2 also, because it is 4, it already have 2 but not 5. That's why we can say it will not end with 0. For example, 12 power n, it will never end with 0. Why? Because 12, if you will write prime factorization of it, it will come 2 power 2 into 2 into 3, right? 4 3 is 12. So all will have n if you will use the law of exponents. So here it is not having 5 as the prime factorization, that's why it will never end with 0. To end with 0, it should have 2 and 5 both as the prime factor. Okay, so here how you will write it in statement form, that is important. So that is the prime factorization of 4n could contain the prime 5. Okay, and if you want to write more precisely, you can write it should contain 2 and 5 both as prime number. This is not possible because 4 power n can also be written as 2 power 2n. So the only prime in the factorization is 4 power n is 2. Only 2 is there, not 5. So the uniqueness of the fundamental theorem of arithmetic guarantee that there are no other primes in the factorization of 4n. So there is no natural number n for which 4 power n ends with the digit 0. So here 4 power n will not end with the digit 0. I explained you why. So the fundamental theorem of arithmetic you have to write clearly. It proves that you have understood the fundamental theorem of arithmetic if you will mention that in your answer. Now you have already learned how to find the HCF and LCM of two positive integers using the fundamental theorem of arithmetic in earlier classes. You have learned this to find without realizing it, means you are not knowing that you are using the fundamental theorem of arithmetic that they are trying to say here. This method is called the prime factorization. You have learned with the name of prime factorization method. So we are going to use that to find the HCF and LCM. And what is HCF LCM? Just a little quick remind of it. HCF means highest common factor. That means what? The highest number which will divide both the numbers. Okay, highest common factor means the highest factor which divide both the numbers. For example, 8 and 16 is there, so highest number which can divide 8 and 16 is 8. And what is LCM? Least common multiple. What is the multiple? Multiple will always be greater than that or equal to the highest number. So least common multiple means what? The common multiple which will come in both the table, that is called LCM. Okay. Now example 2, find the LCM and HCF of 6 and 20 by prime factorization method, which you are doing from your earlier classes. So 6 can be written as 2 into 3, correct? 6 can be written as 2 into 3, 2 power 1 into 3 power 1, and 20 can be written as 2 into 2 into 5, where 2 power 2 and into 5 power 1. So you can find HCF of 6 and 20 as 2, because what you have to see here, it is very important. For HCF, what we see, product of the smallest power of each common prime factor in the number. Smallest power, like 2 is there, 2 is also here. But in which one 2 has minimum power, in which both can give common 2 power 1. So 3 is also here, 3 is not here. So 3 will not come as common. And 5 is here, but 5 is not here. So 5 will not come as common. So only 2 is common. So we can write 2 is the HCF. And for LCM, what we do? Product of the greatest power of each prime factor. Greatest power. Okay. So greatest power of 2 is what? 2 square. So we will take 2 square as in the LCM. Then we will see for 3. For 3, maximum power is 3. 1. So we will take 3. And for 5, 1 is the maximum power. So we will take 5. Now multiply all these numbers. 60 will be the LCM. Hope you are understanding. Listen student, might be you are feeling that these things are going boring, or we are not going with that speed, but only 5-10 minutes video per day will clear your concept of NCERT line by line, and believe me, this will help you in long run, because in exam questions will come from here and lots of concept will get clear. Okay, so what we have learned till now, that HCF is 2. Okay, highest common factor is 2 power 1. Why we have taken this? Because product of the smallest power of each common factor, prime factor in the number, so we have to take the smallest power which is common in both. And for LCM we take the product of the greatest power of each prime factor which is involved in the numbers. Okay, from the example above you might have noticed that HCF into LCM, if you will multiply this with this, so you will get 6 into 20. Now see why it is happening like this. Because in HCF 2 power 1, so 2 power 1 you have taken in HCF, and in LCM what you did, this both 2 you have taken, then 3 also you have taken from here, 5 you have taken from here, so ultimately you have covered everything. So that's why here the formula begins, for any two positive integers a and b, HCF into LCM. So product of the two number is equal to HCF into LCM of two numbers. Okay, it is for two numbers, not for three numbers. That also we will see. We can use this result to find the LCM of two positive integers if we have already found the HCF of the two positive integers. So how we are going to use this concept, that also we will learn in the next video. Hope you are enjoying, student. Write me in the comment section how we can do more better in this. Thank you.